So I have a picture here in my file system. And if I copy the location of it and properly quote it to make sure it's a string, and I use Matlab's function ls to make sure that yes, indeed, it doesn't give me an error, as in it exists. I'm not making any mistakes. I do prefer to construct a piecewise file name from its pieces using Matlab's function fullFile, which you will appreciate later, especially when you go between operating systems. This returns a proper string, ls properly ascertains that it exists, and now I can use Matlab's image read function called imread to read this image. I'll make sure I won't stream it across my image, across my display. I'm going to make sure I call the output of that operation x. It's not working. What's my mistake? Maybe another bracket or one too many. It was one too many. Matlab's function image will then plot that image, and Matlab's function axis with the option image is going to make sure that the ratios of sizes of the pixels are being respected. Let me take this file name and give that a name. I like to call these things fname for file name. What are the various things that I may be able to do? Obviously, X label and Y label, pixel number, column number, and pixel, row number, title. What better word for the title than the full file name? Or perhaps I should take advantage of Matlab's sprintf function to construct a formatted string. What's my format? This thing here. A format string tells me that whatever the next set of inputs is going to be interpreted as, in this case, %s for string. Clearly, in this case, I won't see the difference. But it does give me the flexibility to do other things with it, such as file name, some words, some other things like of a certain size, in pixels. I'm going to make room for an integer times by another integer, and then I'll stick the size of x in the first dimension, the number of rows, and the second dimension, the number of columns, and make that part of my title. sprintf takes a format string, and then for every little format piece that you have indicated by this %sign, it gives that format to the next set of inputs, turns that whole thing into a character string, and then titles that, as we just did. I'll clear my screen, CLC. I don't like the fact that these labels here don't show the first one nor the last one. So I'm going to set those to be something a little bit smarter. For this, I'd better start all over. And as I did in other places, I'm going to create an empty axis using getCurrentAxis or GCA. Call the result AH. And plot my figure on it, label it, title it. AH has these properties called tick. 100, 200, 300, and so on. I'd rather set this to something a little bit smarter. Perhaps I should make sure to make 1 a tick mark. And I'd better make sure that the number of columns is a tick mark. If I do this, it's a little barren. So maybe I should make sure that I label every hundredth. Now I'm not going to type 100, 200, 300, but rather I'm going to say about how many hundreds will I have? That's going to be the size of x divided by 100. I'd better use Matlab's floor function to make sure I round it down. That number is going to be about 6. 1 through 6. 100 through 600. We'll label all the interior points. Now I cannot be sure that if I give it the next image, size x2 isn't also going to be 600. In which case, if I tried setting the same number as tick mark, it's not going to like it. As you see, it's labeling everything 36. In other words, it cannot have any repeated entries. So what I'm going to do, I'm going to start again, create a figure, put the figure on there, label it, title it, and do what I was trying earlier, setting the x tick marks to the unique and sorted set that starts with 1, ends with the end, and then labels all the interior points. I'll do the same for y. That's going to be the first dimension. But equally so, I'm going to label the first point, the last point, and all the interior hundreds. I need to do a couple more things because you see my zebra is being stretched. Axis is another function which, under image, is going to stretch this equally, such that every pixel gets the same width in the x and the y direction, as appropriate. Now let's take a look at what this x actually is. That was the result of reading the image. It's a 424 rows by 687 column by 3 array, and here we're encountering the class uint8, a 1-byte integer. That's enough to have 256 colors, as we can see when we take a look at the first channel of it. Let's plot the first 5 rows and the first 5 columns of this. Those are those numbers, values between 0 and 255. Now, all the reds are all the rows and all the columns of the first channel. All the greens are the second. All the blues are the third. Should I clear X and start again, I can say, all right, it's going to be red in the first, green in the second, blues rather, in the third channel. I've just changed out of X and back into x. Perhaps this is the time to illustrate how to change certain colors, and we might look for the black values or something that comes close to being black. Well, what's black? It's the absence of color. So if I use the logical operation of something being smaller than something else, I could figure out which of the red values are smaller than, let's say, 25. If I evaluate this, what's going to come across my screen is a set of zeros and ones, which are going to be logicals that say yes, 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 or no, no, no. This is smaller or bigger than that value. Perhaps I should take a look at the reds and say, which of those reds are smaller than the number 25? What I get out of this is a whole set of zeros and ones, which are all logicals. Is small red is a variable, which if I look at it, is going to be logical, which is going to be the answer to the question for every one of the possible pixels in the red channel, whether or not it is bigger or smaller than 25, as I'm asking. The advantage of the logicals is that you can use them straight as input to a similar sized and shaped array. So if I change the reds that were reds to another value, say 0 for now, the reds that are small are going to be reassigned to another value. How about I make them yellow, or how about blue? Blue, definitely not red. Let me make a green array that says any of the greens that are smaller than 25, identify them, and then reassign them to another 0. And let me do the same for questioning whether the blues are low, and then reassign the blues that were low to being 255, which means make them all very, very blue. If I now build a new matrix, a new image, that says 1 is my new reds, because I've changed them. 2 is my new greens. 3 is my new blues. Clear my figure and plot this new reassigned image, I'm going to see a very, very blue zebra. Label, label, title. I forgot to assign the number of the axis to a variable, so AH now is gone. It has been deleted. So I'm going to click on this image. GCA will return a number, or rather a property. I'm going to go back and say, well, that needed to have been AH, and so now I'm back. Now I have my axes back. I can go find my y ticks and my x ticks again and recreate what I started. So what you're seeing that we can do now is that we can extract out of x, which is some image in 3 channels, reds, greens, blues, which are flat arrays, matrices with only 2 indices with those color values. Then we can use things like identify logical yes or no, whether the blues are smaller or greater than a certain value. And then we can use these logicals straight into what they were to reassign those positions, yes for reassignment, no for not being reassigned, to any other value that we want. And in this particular case, I set all the values for which blue, green, red were below a certain threshold, to the red, green, blue value of 0, 0, 255, which makes the zebra pretty blue. It's not capturing the whole zebra, so maybe my 25 isn't the best threshold value. I can try this again on my command line. Maybe I should go a little bit higher. Maybe I should make this 50. If this is small, if the reds are small, if the greens are small, smaller than 50, and do my same trick of 1 is the new reds, 2, 3 is the new blues, 2 is the new greens, clear my figure, make a new axis, plot the image, label it in the X, the Y, the title, set the X ticks, set the Y ticks, axis image to not stretch the zebra into a panther, and maybe that's a good value. At this point, we're going to want to script this and later on make a function to do something very, very flexible. And you'll notice that we're halfway on the way to being able to analyze particular images in a quantitative manner, analyzing the presence or absence, the prevalence or the scarcity of certain colors, mapping, adding, calculating, reassigning, and then at every step of the way, looking at the result of our choices, which is why I recommend that you keep your figure window always open, because you will always want to go back between the command line doing something, evaluating it, trying again, and then looking at what it is that you do to your picture.